Well, thank you very much. What a superb introduction, and many thanks for those kind words. I think what one should do is, instead of writing one's own little short CV, one should actually get one's wife to write the introductory CV. It'll be much more interesting to the speaker, who might wake up to a lot of things, as well as the audience learn a lot more interesting facts about the person behind it. I would like to thank the NMMU for inviting me here tonight. It has been pointed out that I'm what is called by the IPCC elite a denialist, a skeptic. In other words, unfortunately, one who doesn't go along with fiction, which is a problem to them. And so I was warned, don't come and debate scientific facts on global warming, unless you wear a bulletproof vest. Now, I've got my bulletproof vest on. This is conflict in climate change. And why conflict? And what conflict is there? We know that the IPCC, put up by the United Nations, tell you that it is actually global warming, which is dangerous, and fortunately has come down from 20 degrees up to 5 degrees up to 2 degrees up now, which will cause great harm. And as such, we have to shut down all our power stations and so on because of the CO2 that's being put in. And it is we, who are bigger than nature, who are changing the climate. Now, that is quite a thing to bite at first. We really are quite impressive to do that. And so, what is the current state? Is there any doubt? In the last 75 years, the Earth has cooled for 23 years, it has warmed for 25 years, and then has not warmed for now 18 years. It has not warmed for 18 years, and the IPCC are still talking about global warming. 1/3 of the last 65 years, and they only talk there, they don't talk back about nature. Only that time actually fits, and I'm just starting. So, because of this, gazillions of dollars, and I mean this is into trillions, are being spent by governments on a whole lot of work which could cripple economies, including this of South Africa. Things like carbon tax, for instance. I shan't go into the political side, I'll try and stay scientific. So what typifies this context, this conflict? First of all, the IPCC is CO2-driven anthropogenic global warming, AGW, and it is an intergovernmental panel. It is picked by the United Nations, and it has governmental people, and it is an alarmist organization, which is quite a state to be in, but all of you have heard the dangers which I deal with. Then there's the non-governmental international panel on climate change, which is 10 years old now, had its 10th conference 2 weeks ago in Washington, which looks at the sun, sunspots, solar Earth cyclicities, which we'll come to, in terms of the cosmic and magnetosphere. Anyone who was here at Michael Kosh's talk at midday should appreciate it's right up my line. And thank you, Michael, for introducing some things. You'll see some repetitions of that. It is international. It is not intergovernmental. It doesn't have government heads. And it says adapt to nature. So that's a conflict. This was said by James Lovelock, founding father of Gaia. We live at a time when emotions and feelings count more than truth, and there's a vast ignorance of science. And I think that's exactly true, that people believe the media and one does ignore the science at one's peril. Let's look at the IPCC AR5. I'll show you later what that is, but that is their last conference report, major report in 2013, and they said the following. It is extremely likely, and they spell this out. I'm sorry, is this mic in the right place? They spell it out. That means 95% probability that the human influence has been the dominant cause of observed warming since the mid-20th century. Now, that's why I picked out the last 75 years. They're talking 65 years, but over that time, they've sort of lost out a bit. Who all think, it'd be very interesting, I actually need lights up, but who all think, yes, they're right? There must be at least one of you here. Yes, yes, yes. Heavens amongst the multitudes. Heavens, yes. Great. Okay. Well then, for interest, who thinks no? Oh, good heavens, we've got quite a few converts. Excellent. But there's some 285 people who don't think at all here. So what is climate change all about? It really, there always has been change. For 4.5 billion years that the Earth has been there's been climate change. We can't get back much beyond 500 million years. That's difficult to get to, but we can get back there. And at the moment, is it getting exactly what you said? Is it getting hotter? See, IPCC says, and we're going to have deserts and a few little bits of greenery because CO2 is good for greenery. Or is it not CO2? And is it going to be green because of the CO2, but not global warming so dry? Or the question is it going to go into a Maunder minimum when we were ice skating on the Thames just 300 years ago? When they say it's been warming since 1850, of course it's been warming. But they didn't talk about the previous 500 years when it was cooling, or the previous when it was warming. We'll get to it. And so what are the climate change facts? Nobody denies that there's a climate change. There always has been. Nobody denies we had some warming since 1850, and it's actually modest compared to previous warm periods. Nobody denies that humanity has added CO2, but small compared to the natural outgassing of the oceans, which holds 80% of the CO2. Nobody doubts there are bouts of extreme weather. There always has been, and anyone who's interested, you can get bouts of extreme weather. Look back the last 1,000 years, you'll find some real extremes. Go back 10,000 years, you'll find some tremendous extremes. But nobody denies that the Intergovernmental Panel on Climate Change, the IPCC, has become an all-powerful, formal global player who claim authority that anthropogenic CO2 is the driver of dangerous and alarming global warming. And that is what hits the public. So let's have a look now at global warming and the UN and IPCC. This was set up by the United Nations in terms of their Framework Convention on Climate Change, and it was set up in 1988, which means they've had about 25 years of operation, and they've spent over $100 billion so far. They don't do any research. They just read research articles and then get their conclusions from that. There are 195 member countries. About 20% of them actually conduct climate change, and the rest send, for me, political members to attend and vote accordingly. It is actually a desperately political group. They've got 2,700 members who are appointed, and therefore they are answerable to the piper who pays them. The agencies are governmental agencies, NASA, NOAA, that's National Oceanic and Atmospheric Administration, and the Green Climate Fund. The Green Climate Fund, I might say, has got $10 billion, and it has just asked for immunity from any challenge to what it says or writes. And America has said, no, you are not a UN organization, and so I believe that the Greens will be quite a lot more quiet now about some of the incredible things that they say. And the media, global promotions, it was interesting. I was interviewed this morning on Radio Angola, and the interview was superb. Darren Mann said, but the media says, and I said, that's the trouble, you're the media. And everyone listens to you, but you don't listen to the right people. So I'm sorry, I'm singing praises, but perhaps I'll convince you. The IPCC have produced reports Their first one, FAR, their first in 1990, second in 1995, third TAR in 2001. They hadn't thought that if they had a fourth one, it would be called FAR, which unfortunately conflicts with the first one, so they had to change their nomenclature after 4 and call it the AR4, and then the AR5 in 2013. So please, when we go through these, try and remember which is which. They are noted for their alarmism, and in particular, the sea level rise threatens all coastal cities. I don't know if you saw, but Cape Town's the latest one, by the way. Port Elizabeth, you're safe so far. Greens haven't been here, have they? Watch out. Watch out. Arctic. There's a deliberate mistake. I knew there would be one. The Arctic ice will disappear by 2014. Polar bears are threatened. Droughts will occur, all sorts of nasty things. Global warming heads out of control. Now, my honest assessment, I used to talk global warming still 6 years ago, by the way. What I believe now is that global heads are out of control. And really, they need a rethink. But you know, when you've got something going, it's quite difficult to backtrack on it. And that is not going to be our planet. Please don't worry. We're not going to suffer heat stroke. There's a lot more that will keep us going. Let's talk about greenhouse gases, because this is important also for what I'm going to talk about. And that is the role of them. And of course, your main radiation, 99.9% of your heat, comes from the sun. They seem to forget that the heat comes from the sun. And what happens is about a third of it gets reflected either by clouds or by the surface. So you get some being then emitted again. Also, of course, some goes down and is absorbed by the surface and also absorbed by the atmosphere. It, in terms, radiates upwards, hits the clouds, interacts with the clouds, and you get back radiation, and this is long-wave radiation, some leaking through, that greenhouse gases play a role there, some leaking through and some going out. And the point is, let me see, where is this? This is it. That is your input, has to match your output plus your output. If this is lower because greenhouse gases absorb more, you're going to overheat. That, in short, is what the story is about. But the clouds come in. And the role of the clouds is important because what they also do is they actually here play against the incoming solar radiation, which we'll point out. And so they alter the total heat which is reflected or absorbed. So the clouds play a role not only in reflecting, but also in actually attenuating the input. We'll look at greenhouse gases in particular and see what are they all about. That red square, that green square shows the percentage of the Earth's total greenhouse envelope. It's 95% natural from water vapor. If we didn't have that, we'd be at a temperature of minus 19 degrees, and we would all be sitting here in polar bear skins, and there wouldn't be any more polar bears. But you have 1.4% methane, and you've got nitrous oxide. And here you've got 3.48% natural CO2. Remember that 80% nitrogen is out. Remember that the hydrogen is out. And here at the bottom, we have 0.12% of man-made anthropogenic CO2. And we are impacting on nature if we go from 0.12 to 0.13. Watch it. I'm going to give you a hard time, because this is a physics conference. But I'm sure you'll live with me. These are going to be graphs of, yes? Let me try and get my vocal cords closer to it. So here, don't mind, you must never turn your back on the multitudes. I'm going to. Here, you've got millions of years ago. We're going to go back 542 million years ago, and here we're going to have temperature from hot and cold. And one other thing that I'll always put in for you is, this is in the quaternary, so I'll always put a red dot in to show you at which end we are now. Because sometimes we'll go backwards that way, and sometimes we'll go backwards this way. Apologies, but this is all original data that I'm giving you. So what else do we know? That before that time, before the Precambrian time, you had a snowball Earth, totally iced, cold as charity. And then, is it coming? Thanks. Sounds like we're coming back. Anyway, talking about this, I mean, we're talking about a long time ago, and you will see that there are glaciation periods, which are both the Sahara, about 460 million years ago, which is the Ordovician Silurian period, where there were great extinctions, where the temperature dropped dramatically, and at that time, the carbon dioxide level was 10 times what it is now. And there was a global massive cooling. Then the so-called Karoo glaciation, which if you go up to Kalahari, you will be able to look at rocks there where you see the ice that scraped off. That was about 300 million years ago, which is the Permian extinction. Again, the level there was about 400 ppm. So the same as it is now, but you had a massive extinction. One then goes to, from a little reasonable time before, which was about 260, 270 ppm, and we've had this very sudden climb, I will show you, of temperature, which is quite dramatic. Again, that period is not really typical of the Earth. It was a very different Earth at that time. I will skip, actually, but finally come back at the end to a period which goes out to 450,000 years ago, because there we're going to see a lot of light on the solar impact. I'll also be getting closer and closer to where the IPC work, which on that diagram, oh, voila, we're back. On that diagram is hardly there. Do you mind if I carry on without the lights? Okay. So in this, the CO2 levels, as I mentioned, is 4,000 ppm, 10 times 400 ppm. There's a period here of a greenhouse effect where at 1,000 ppm, the whole Earth was green. This temperature here, by the way, is our temperature now. And what I'm going to look at is jump forward and take a slice out of here, except the slice is going to be thinner than that line. So this is just schematic of dumping down to a period now where we came out of a deep ice age about 11,300 years ago. And that, again, is shown here in terms of temperature against going back to 10,000 years, and also CO2 here going back against 10,000, 11,000 years. One of the things here is I've put in the extra little dots to say where our temperature has gone up to. This was done, and that's where the CO2 has gone for the moment. And that is where we came out of the ice age, which goes down through the floor round about there. Person who was going to help me, sorry, that's exactly. So we've come out a long way, and look at this interesting thing. You've got structure here all along. And I've checked up. There were no power stations at the time of the Egyptians, and there were no power stations back here. So somehow something was going on there, which is now going on here. Well, okay, we'll live with that. This is what happened to the CO2, up from 260 to 280, and then voila, up to 400. Remember 350 was a critical time? Now 400 is a critical time. In physics, it might have been 411.7 for a physical reason. For them, 400 is a number that you can remember. Doesn't mean anything in terms of the physics. This is the 3,000 years of interest, which we'll come to, which goes back to a period which is becoming more and more interesting to us. At present, we're in the little warm period, then the little ice age, then a warm period again, the medieval warming 1,000 years ago. Before that, there was the Dark Ages cold. Before that, there was the Roman warming period, when they grew vines in Scotland. And before that, there was the Minoan warming period. And so let's now see that the CO2 here was increasing all the time while the temperature actually was decreasing. Very, very, very interesting. We'll take this, and you can see we are now homing in on that right angle, on the right side of the original slide. But now I'm going to have to turn you around because we're now there. So please now go backwards from now, back to 0, back to 1000 BC. And what we see is, from what I showed you, remains of the Roman period with vineyards, Dark Ages, medieval warming period, Doomsday Book, Little Ice Age, Maunder Minimum, and out came in 1999 a new thing called the hockey stick. And the hockey stick, I blame for most of the trouble today, was brought in by Michael Mann and the British colleagues at the University of East Anglia, and they produced this stick, which was straight there, ignoring, and then here they used some English results to put up a dramatic peak to say, hey, friends, something's happening. And that is what they said at that time. Hansen said 20 degrees by 2100. Those of you who remember, if not, go back to the records, 20 degrees. Then they said 5 degrees by 2100. Now they say 2 degrees by 2100. I predict that it'll be 1 degrees next year, and the next year I think the IPCC won't exist. So now let's get even closer to home. Let's start really talking about the last 1,000 years. And here they are. And let's go to the IPCC first 3 reports. And what they had was IPCC hand digitized from IPC 1990. And look, voila, can you see? There's a medieval warming period. And there's a little ice age, and it goes up there. This is the FAR and SAI, the first and second reports. Then what happens? Oh, sorry, Moberg, I shan't deal with that. I'm already behind time. Then Mann came along with his classic, what he called his millennial Northern Hemisphere temperature restructuring. And he used on top of that Central England temperatures from Jones et al. To take this green up to there. And so that was in the 3rd annual report. In 2001 was in fact this hockey stick. That's in 2001 they had the hockey stick. And they had a problem after that. Sorry, I can see I must talk down here. Is that better? This is the book that's written by Montford that says the hockey stick illusion, ClimateGate and the corruption of science, because I must show you in between, sorry, the US Historical Climate Network. This is what you can do with things, by the way, if you feel you're not happy. You'll see here, for that one, it's when they were at 2000, and then they went on, and it had to be global warming. So the results are quietly changed. This is from the US Historical Climate Network. And I can show you a lot of others if you want to. And ClimateGate in 2001 was when they got all the emails and proved that there was Schlenter going on, that they were actually modifying their stuff. So that's a problem with a physicist, any PhD, MSc students. It's a problem, it really is. Don't do it, not if I'm your supervisor. At the same time, Svensmark wrote on the influence of cosmic rays on Earth's climate, and the IPCC ignored him. This is what the Maunder period looked like. Fairs on the Thames. It was a period 1645 to 1715, and it was a massive cold period when people were very unhappy. And in fact, if you want to have the option, rather go warm than cold. Really, if that's your option. Oh, sorry. This is where you might be, but I'm hoping not. Very interesting, because this is the summary of 5 of the major measurements of climate temperature between 1980 and 2015. We're up here. and 3 of them are earthbound. Hadcrut, which is a CRU from East Anglia. That's a Goddard Center, this is National Climate, this is University of Alabama. These 2 and remote are on satellite, and these 2 are on ground-based. Now, the trouble with ground-based temperatures is that you get certain heat islands, you get the modification of where they are. For instance, the IPCC, out of 60 measurements in North Canada, took out 59 of their measurement points, which sort of alters a temperature. And here, if one looks at that's over the past century, it heated at about 0.08 degrees centigrade per decade. This is what has to be done if the IPCC are going to get to 2 degrees. And of course, this is what's happened over the past 18 years. So we'll look at the past 18 years, and there it is. No global warming for 18 years, while the CO2 went up by 9%. Now, there are a lot of arrows here. Those are to do with various factors in terms of oceanic currents. I'm not going to be able to talk about them, sorry. That's just the ocean heat, and that we will skip. So let's take a look at the results of the IPCC model calculations. Now, these are non-local, coupled, chaotic calculations which were stated by them could not predict the future. Well, let's see. And this is, I'm taking from this, forgive me, but this is from their report. And you'll see a lot of spaghetti up here. See all the spaghetti. Now, the spaghetti is 73 IPCC climate models, 1975 to 2000, in the AR5, presented. They said confident, increased confidence, likely 66, very likely, extremely likely 95%. Let's go through this. Those are the experimental results. And I've actually mixed them a bit because they should be flatter along here and then down. And so what did they say in FAR, in the first one? They said they were confident. Then they said they had increased confidence. Absolutely. I couldn't agree more. Then they said it's likely with 66%. Niemand, no water. Then they said very likely 90%. And this is when I changed sides. And then they said 95%. 95% confident, and this is what you're listening to. Let's look at the fingerprint of IPCC models. One of the important things is the troposphere going up to about the flight path of airplanes at 11 kilometers up, 11,000 feet up. And they predict a hot spot in the troposphere in order to bring about their temperatures. So here, what we have is the troposphere from ground level here up to where the airplanes fly. This is the temperature that they measure, and this is where the experimental results are, from balloons, from satellites, from all sorts, from radiosondes and so on. And this is the spaghetti. And that's their average. And what worries me is they can't get Johannesburg right, and they certainly can't get where their major impact is right. And you know what? I'll give you a guess. How confident are they? 95%. They've got stuck on it. Richard Linson is a powerhouse in the NIPCC, and I mean, he came out with this. I think that the latest IPCC report has truly sunk to the level of hilarious incoherence. They are proclaiming increased confidence in their models as the discrepancies between their models and observations increase. So here. I've read the IPCC reports, IPCC. There's working group 1, 2, and 3. 1 is really the physics, and the others that I might come to. But this is one of their statements where they're not sure. The scarcity of robust scientific evidence supporting the attributes of observed impacts to climate change in some vulnerable regions does not indicate that no such impacts have occurred. Lekker. What does it mean? Stated things without evidence. And that's exactly what is there. In fact, they've also kept stuff out. That last one on the tropospheric was kept out of the AR5. It was asked to be put in the AR5, it was taken out. This is another recent statement by Chris Folland of the Hadley Center. The data doesn't matter. We're not basing our recommendations on the data, we're basing them on the climate models. And then another lovely one. A global warming treaty must be implemented even if there is no scientific evidence to back the enhanced greenhouse effect. Richard Benedict, Deputy. Now we've got COP21 coming up in December, and that's where it's going to be decided as to how the future is going to go politically and governmentally. And there's a huge drive for that. I'm now going to turn my attention from this side to this side. What about sea level rise? Well, let's have a look from 1880 to 2000. And in fact, it's been around about 2 to 3 millimeters per year for all the time. It's been steady. These are measured with tidal gauge records. And one of the things is that, for instance, in Sydney Harbour, they've worked out that that tidal gauge measuring device has been sinking by 0.49 millimeters per year. Now, is it the sea rising or is it the ground sinking? And that's why you've got to go to satellites, because they're not interested in that. They're interested in absolute heights. And when you look at the global stuff, which came in from 1992, we're up there, remember? This is the rate. It is up 3.2 plus or minus 0.4 millimeters per year. Here's an interesting little excursion around about 2011, 2012. I'll talk to you about it. But basically, there's no increasing rate in sea level rise for a century. But please be scared. I've worked out, we live 11 meters above sea level, and I've only got 28,000 years left before I start swimming. This is NASA results. I wish I'd done that earlier. NASA results. August 2012, August 2013. The Arctic ice sheet grew over 1 million square kilometers in 1 year. It grew from 2013 to 2014. It's still up there. It is back to 1976 levels. Have you heard from Greenpeace or the IPC about the Arctic lately? No, not a peep, not a peep. And then, okay, Atlantic multi-decadal oscillation, AMO. Sorry, I won't get into ocean, but it's very fascinating. This is a bargain. Would you remember Al Gore? Because he's got a book on sale for $1, which is really, I think, a super buy. If you are interested in ancient mythology, I think it's great. And this is Al Gore, Nobel Prize winner, acceptance speech 2007. The North Pole ice cap is falling off a cliff and could be gone in 7 years. That was last year. The chief polar bear has told me that Al Gore is going to fall off his ladder that he climbed up within 7 years. So please, it's a statement I hope to have corroborated. But there was a chancer of first order. And this, for your interest, if you want to go to WUWT, look at sea levels, and you will get them up to yesterday. You'll see sea ice extension and so on. I'm sorry, I last looked at this about 5 days ago, but there is 2011, and this is really when, in the summer when it matters, low. There's 2012, there's 2013, there's 2014. Here, we're coming down in 2015. We wait and see. Not predicting anything, but I wait and see. The trouble with media is it also gets through other channels, and Pope Francis, on the 15th of June, just recently, spoke about the residence time for CO2 in the atmosphere, and he said, the long lifetime of greenhouse gases means that it is a cumulative buildup in the atmosphere that matters most. Now, fortunately, he gets his advisors from Greenpeace, which is quite fascinating, because let's look at that residence time. And if we go back 200 years, we see the IPCC model says between 50 and 200 years, and here it is still at 20%, so it goes out for 1,000 years. This is the latest carbon-14 measurement, 4 to 7 years, And with all the chemistry going on, you might look at 50 years at the most. Unfortunately, the Pope has got it wrong. And I blame it not on the Pope. I think he's a very reasonable person, but he should use his advisors better. This is apocryphal. It's not Bill Cosby, but it's essentially what I feel. I'm tired of being told I must lower my living standard to fight global warming, which no one is allowed to debate. And I speak that as a denialist because I personally have been denied the opportunity to talk. And that's why I thank NMU again for opening the scientific debate to say, what else is there? The Economist, last year started, The Economist is very pro, and they said, you know, finally after decades, we're now in lockstep. All marching to climate change is real. But unfortunately, now on to the next steps, and you will see the Greens and the IPCC, and you'll see a few others marching, and you'll see a few going the wrong way. You'll see me there. And basically, it is true that life is now looking more reasonable in terms of the physics, as the public are beginning to realize that something smells in the state of Denmark or the IPCC, wherever that is, and one should be aware of it. They might be right. I'm not saying they're wrong, but I'm saying the chances that they're right are very small. How do they work? It's a circus of success. Scientists make meaningless or ambiguous statements. That goes on to advocates and media who translate them into alarmist declarations. That goes to politicians who respond to alarm by feeding scientists more money. And then it comes on to the faithful make even more outrageous or ambiguous statements to bolster as the state worsens. People are actually, I've spoken to a few and said, please get out of this before you're embarrassed. But you must realize there's a problem. As an academic professor of climatology who's been talking CO2 for the last 8 years to his students, to back down on that is going to take guts. I ask him to have guts. Climate change driver, nature and our sun. Let's look at our sun. No, I'm not coming back yet, I'll come back later. Solar spot 11-year cycle is fascinating because this is the Earth as it goes through a cycle. It's very bright, and then it goes down to the quiet part, and then it comes back up again and it's bright again, and then it does that loop again, and it does the loop again for hundreds of thousands of years. And that's the 11-year cycle of the sunspot cycle, which will play a role. And see what the NIPC says in terms of solar cycles. These are the latest solar cycles, 1983 to 2014. I put in the 2015 point there. Sorry, the data is about 3 months old. And I noted Michael Koch also couldn't get any new data on this, which is a difference. By the way, the IPCC tend to end their data at around about 2010, 2011. Don't buy it. It's 2015. A lot has happened. And here you see the solar spot cycle 22 went up to its max, number of sunspots, down again to very low, up again, down. But this is the trend. This is the trend. And that's a quiet sun. In 2007, 2008, it was virtually quiet for 2 years. Those are sunspots. And they've been looked at since 1600, since Galileo got a telescope. And that is what the Earth looks like if you look at it over a long time. There are mass ejections, there are coronal, but it is a very active sun, which does impact on us. And so this is the role where if you've got the sun out here, and you've got, let's bring the Earth in. The Earth had better be there. And it has a magnetic field around it, which is all very well and normal like a dipole, except the pressure of the solar wind alters that. And when you get the solar wind up, the magnetosphere comes into power, and that's an ionized area, and cosmic rays that come in get blocked. And when the solar wind goes down again, the geomagnetosphere drops, and would you guess? They come into Earth, cosmic. This is going to be important. It's going to be important. So let's look at the variations in solar activity. First of all, here you have the solar activity, and its irradiance, its total solar irradiance comes down, and this varies by not more than 0.1%. The sun does not vary much over this time. Don't talk about the sun warming and cooling and so on. It is pretty solid. It varies. But you have a solar wind that comes out from those ejections and from which in fact hits the magnetospheric response, and it even shows on the Earth's rotation. So this isn't pulled out of the sky. This is an impact on Earth. What else do we have? We have cosmic rays up there which come in, and they say, uh-oh, the sun is busy, there's a solar wind, I'm blocked, but when it goes quiet, then it comes through, and we detect this in terms of carbon-14 and beryllium-10 nuclear techniques, and we can detect back for thousands of years. And these form cloud formation, and cloud formation, as you saw before, has interest in the Earth's climate change, as well as the incoming solar radiance, which is there. So cloud formation, through this role, alters the actual TSI on the Earth. This, by the way, is at CERN, at the Large Hadron Collider, on one of the satellite beams. It's called the Cosmic Ray Experiment Cloud Formation. You can alter all the conditions in this chamber, put very high energy beams in there, and see about the formation and the seeding of clouds in terms of cosmic rays. So this isn't just pie in the sky. Let's go back then and start saying, hey, what can we deduce from the past? And if we look at the sunspot and cosmic ray, we see here beryllium-10 concentration, which it tells you about what the cosmic rays have been doing. Whoosh, whoosh. And then if you look at the Galileo telescope, you'll see that they started looking at the sunspot number, and here they weren't asleep. They were measuring, and they were very worried, but they were having no sunspots, and it went up, and it went down again, and it went up. And the interesting thing is the correlation between the cosmic rays and this, and correlation there and there. And why is it correlated? Because that's the Maunder minimum, and that's the Dalton minimum. Now, that might be by chance. It could be by chance. But it certainly has a certain story for me. By the way, 1400 was the time when the Earth was the center of the solar system, and it took to 1600 to work out that the sun was at the center. I believe the same is true of IPCC and climate change. It's going to take a little while to get rid of the religion and get to the fact. That's where we are now, and we're coming down. I'll come to this later. This is the data from 1850 to 2010, again, of the atmospheric CO2 level against the global temperature from 1850 to 2010. And that's the temperature, and this is what CO2 did. Now, that is where we are at the moment because we've been flat. So what happened there? This is where it went up, and CO2 is dominant. It turns on. All the power stations were emitting. But here from 1940 to 73, it cooled. Now that's a bugger. Really, so what you do is you forget about that. You just start from here. And if you start from there, you're fine until now, when you run into problems. And this area here, CO2 doesn't increase fast enough for the temperature rise. This is Mount Pinatubo, by the way. You have huge throwout, which again, instead of clouds, puts in blocking radiation, and you get this sort of event. Let's go, remember the TSI, total solar incidence? Here you see the 11-spot sun cycle. Here you see its impact on the total solar incidence. I don't know. And just to make sure, Time magazine in 1974 said a series of, and it's a long story of unusually cold winters has gripped the American far west, while in New England and Northern Europe, and we've had droughts and we've had climate change and all the rest of it. And it got to the stage where they said, how to survive the coming ice age. 1974, Time magazine. 1988, we worried about global cooling. 2010, we're ready to shut down power stations. Yeah, Time magazine, just don't trust it. Let's look at cloud cover versus cosmic rays. This is 1980 to 2010, thereabouts. And that's cycle 22, and that's cycle 23 that I showed you before of the cycles of sunspot. And you've got low cloud cover, and you've got cosmic ray. Sometimes they inverse, but at least there's a correlation there. I've only just started. I'm coming to this side, giving you a break. Wow. Sorry. I've only got an hour to go, don't worry. Milankovitch cycles are here, and let me go back rather. And I'll come across here. Milankovitch cycles are sun, solar, earth cycles. And what you have is the earth going around. That's not once a year. This is over 100,000 years. The eccentricity changes from an oval to a circle, to an oval, to a circle, and so the distance to the sun changes with the eccentricity of 100,000 years. Show you that. Then the obliquity of the ecliptic, which is the angle at which the Earth rotates. It varies between 22 and 24.5 degrees. It's now 23.44 if you want to know exactly. And that varies over a period of 41,000 years, there. And then you get precession at 26,000 years, whereby this thing precesses about its axis, like that. I put this in to try and explain better. That's what the eccentricity does. That's what the obliquity does, changing there. And this is precession. In 26,000 years' time, you won't look at the North Star looking north, you'll look at Vega. So all those who do astrology, you'd better get your numbers right, because things change. I'm going to skip this. No, I'll do it very quick. Sunspots are there, and you will see that this is over 2 cycles. Your cosmic rays vary with the sunspots. Your X-rays vary as well. Your protons vary. Michael Koch will do far better than I can do on this. If you have any questions, I hope he's in the audience. You can ask him. But certainly what you see is sunspots have a definite influence on cosmic. Let's go further and say, over the last 1,000,000 years, 1,000 kiloyears ago, we look at the stages of glaciation. This is hot, this is cold. And we look at the precession calculations, the obliquity, the eccentricity, that's the 100,000, and the solar forcing as a result of this, and you get the following. I don't know about you, but there's a certain sort of coffee break pleasantness about this. It really does say something to you. And that is, really the 100,000-year cycle, they're the 41-year, they're the 26-year precession. This is the very latest on the sunspot cycles where we are now. We're right now, this is the projection down here, and we are right now down about there. So we are, in fact, for the previous cycle, and we're on our way down to a quiet sun. And so let's go back to the Dalton period. We can't go back to Galileo to see how you enter into the Maunder minimum because that data is not solid enough and it's not long enough. But we can go to the Dalton period, and that is the period from 1800 to 1830, where you can see in the blue the sunspot activity going down, down, And in the red, if we go from 1990 up to now, this is what we see. This was short, but we had very, very quiet sun there. And what is interesting is that after that, one developed an interesting added bit that if I add what we've measured since this diagram came out, unfortunately this diagram came out about 4 years ago, I've added in what's happened since there has been a second bigger peak on this particular one. And so we are now sitting somewhere round about there. And we're going into a very quiet period, which is the quiet period that the Dalton cycle went into when it was cold. It was viciously cold. This is the big talk. Sunspot activity 1700 to 2010. And this is where we are. And that's the Dalton minimum. And why I pointed out is these are sunspots. That's the big, down, smaller, smaller that we've just looked at. And of course, these are the 11-year sunspots activities over the years. If we look back further, the Maunder minimum was back there, around about 1645 to 1715, when it was very quiet. In fact, it was incredibly quiet. Then we going backwards to the Little Ice Age. We look at the Dalton data, and we go forward and we say, as the Russians and several others are now doing, and those were projections, by the way, by the Russians, what about the new Little Ice Age by 2040? Because if this is going on, then we should be ready for it. Would there be a Little Ice Age then? And the person who predicted this was Theodore Landscheit. I've got to be careful. But it's going to be called the Landscheit minimum. What I'm grateful for, it's not going to be called the Landscheit maximum, because that sounds like pollution. The resulting problem that one must become aware of is the advent of consensus science. And this is where the IPC are tops. If you get 100 people voting that it's too hot in this hall, the one person who's got a thermometer and says it's colder is outvoted. He says, I can see the temperature. They say, you're wrong. And perhaps this is best illustrated by the statement, blatantly incorrect, that 97% of climate scientists believe that CO2 is the driver in climate change. Absolute rubbish. They've gone back in NIPC. There were 11,744 papers that were studied by this person, Thomas. He disregarded 7,000 of them. He got down to 64 papers. This is in the literature. 64 papers that were positive, 41 may be positive, and from that got 97%. And what I say is what is correct is 97% of climate scientists believe that CO2 is a driver. I believe it. I believe that CO2 is a greenhouse gas, it's a driver, but it's a minimal driver. It's such a little that when the oceans give vent to a little temperature rise, it gives off CO2, which is massive. It's 80% of the CO2. And a little temperature rise gives off much more than our 0.12 plus an extra if it ever comes into operation coal-fired station. We're doing wonderfully for coal. Really, every time we delay our coal future, we help global change. But we're going to die for it. And remember, this gets into government hands, and that is the nearest thing to eternal life. Once you get those people who have dealt, it really is tough. More and more scientists follow the NIPCC, and more now believe that IPCC are totally on the wrong track. They use stronger words, talk about mendacity, which is a very nice, powerful word which no one understands except it means lies. I believe there's mendacity in the IPCC. I'm going to end off by showing you again, looking back at 8,000 years, and say we'll come back to the medieval period, and these are the temperature rises that they talk about, 2 degrees, 5 degrees, and they used to talk about 20 degrees. and their maximum, they say, is 6 degrees up there. And so here, we would be a little bit hotter than the Romans. And so the fights with the Gauls would be much more interesting when it's a little hotter. The thing is, it's easier to ride a horse in the direction it's going. And that's the way the IPCC are going. It's very difficult to backtrack when you spend 100 billion, you've influenced governments of the world, you've put in a whole lot of wind turbines, you want to close down and put carbon tax on coal-fired stations, which provide 90% of our energy, because you're going in that direction, and you're too calm to say, jammer, jammer. Let's go a bit further back, and again, this is where we are now, but I'll go back to 50,000 years, and you'll see that over this period, remember I said we came out of a deep ice age? Well, this is part of the 100,000-year deep glaciation period, and over this rise into what was the Holocene, and this is the 8,000, 10,000 year, the sea rose 103 meters. And that's not because ice melted, it's because ice on land melted and went into the sea. Snapshot for first-year students. You melt ice, does the level of water rise? Does it go up? Or do we turn around and start thinking, hey, maybe it's going down? And so I'll give you one last one, which is over the 400,000 years, because this is quite interesting. Because here's your 100,000-year cyclicity of the sun eccentricity. You've got 46,000-year periods here as well. And if you go back, you will see that these are glacial periods every 100,000 years. And in between, you get interglacials of about 15,000 years long. And they are all up there, there, there. And we are sitting here. And we are sitting here for just on 12,000 years. And so with an impending global warming alarm, would you go up that way and sort of forget about the last 400,000 years? Or do you think we go sideways? Perfectly likely. Or do you think we have a glacial entry and we go down? Well, I have, from the wind, knowledge that climate change is changing in Port Elizabeth. But Port Elizabeth also, and other sea coasts, have given me one other proof of anthropogenic CO2 driven global warming, and the reason for real alarm. And that is this. This is positive proof. And I'm looking to 2016. I'll be in Kenton-on-Sea with my eyeballs out. But what does that mean for my philosophy this evening? Not philosophy, my science. It means we'll go back to bloomers. That's rather disappointing, but it's factual. CO2 is alarming. Methinks they protested too much. And then there's a beautiful statement by Horace, just pre-BC, Parturion Montes Nascitio Ridiculus Mus. The mountain has given birth to a ridiculous mouse, a very expensive mouse. Climate change is natural, has been since the beginning of the earth. Climate science is nowhere settled. It's not settled. Adapt or die, but don't give your winter woolies away. You prefer the little ice age might cometh. And so I've been warned by friends that they do not know how one dares to challenge CO2-driven global warming with mere scientific debate. I thank you. I haven't needed my bulletproof vest, and I really appreciate that. But I believe in Mahatma Gandhi. And he said, first they ignore you, then they laugh at you, then they fight you, then you win. Thanks very much.
Thank you very much, Don. This has been really a wonderful, fantastic, beautiful. I don't know how to describe it. I just want to use the opportunity to market physics also to the people who are not a part of the SAIP. Why do we need people like Don? Because they can distinguish fact from fiction. And I think this is one of the most important roles that physics people can play. And in terms of energy solutions for South Africa, many, many other things, he has good answers for that. Now over to you. You are welcome to ask him anything, but please remain polite because this is a very sensitive issue. I will immediately interrupt you if you don't stick to the rules. So over to you. You can use the microphones there, and we hope you have very interesting questions to ask.
Could we have the lights up a little bit, please? Is there anybody with the lights? Eskom! You're not listening. It's very difficult actually to just see two headlights coming at you and nothing else. And hello.
Hi there. The question is, qui bono? Who benefits from this delusion? This brainwashing about climate change. Who benefits from this continual brainwashing? Thanks, Don.
Oh dear, I've got a list of beneficiaries. I haven't brought it with me. It's 5 pages long. But for instance, the wind industry benefits tremendously. Those who are in climatology are getting funding for their research, and as such, to be a no-sayer is to end your employment. I think that all the government agencies are dead scared because they ruled from a top. It is a politically made decision as to where they're going, and in fact, Paris COP is going to be in 21, is going to be a political thing. Let me inform you about the IPCC, how they do it. They have working groups 1, 2, and 3 when they come out with their reports. But what they do is they put out a first summary of this to the political parties, having gone to COP with that, and then decisions are made, and after that, they release the physics data. And I'd like to defend the IPCC. A lot of their physicists are waking up. A lot of them are leaving. But it's an inverse reaction, whereby it's a political drive, and the people who benefit are obviously those with vested interests. And the vested interests are many, but basically concerns this. I don't know if that, do you want a more complete list? You know, oh no, I won't mention his name.
Don,
Yes.
thank you very much for a wonderful presentation. I was sitting on the wire, more or less. You haven't quite convinced me that CO2 is not causing a global warming. However, I'll accept your view at the moment as being a good one, because I don't think that it is totally proven, the whole hockey stick idea, but what I believe is that we should not throw rubbish in the atmosphere. And even though CO2 might not be the agent for global warming, it is still a good idea to keep our atmosphere clean. That's the first point I'd like to make in your comment on that. And so I would agree with those that think that we should go to nuclear power. And what is your view about that? And the third point is, and I think you partially answered that, what is driving the mendacity at the IPCC?
Yeah, thanks very much, Henny. Very good to see you as a person I've known for many, many years and respected. However, tonight you, for the first time, said something with a little stop, a glottal stop, which worried me. You said, I don't think that the other, I take it it's not that you don't think, it's that you, okay, I needed to clear that. Look, let me get to the energy, first of all. It is a big problem with the economic state of it. But if you look at the reactors that are available at the moment, you'll find the ones from the Russians, the VVER 1200 and 1000 are very good. They're exporting them. England is probably going to buy 3, having given up on the Arriva, because that's 75,000 to 80,000 rand per kilowatt, whereas the Russians are about 55. The Chinese are building 28 at the moment. They're exporting, but they're based on the Westinghouse design. The South Koreans, of course, are 45% nuclear, and they've got virtually their own. They're also selling at about the same 55,000, Chinese as well. The Americans are out of it with Westinghouse, I think. And Arriva, the French, British, European EPR 1600, which is supposed to go to England in Hinkley Point, has now had 2 massive failures, one in Finland, one in France, where they said the language wouldn't deter them, and the third one is now in England, where they are bringing in 40% of the Chinese management to manage a thing, because the Chinese can put these things together. And the question with the EPR is it's got over-the-top safeties. So if you don't like meringues, it warns the kitchen. Henny's coming, he doesn't like meringues. That might cause him to be unhappy or tummy, and then he'll push the wrong lever, and then the reactor will scram, and then we'll kill 42 million people. Well, you like meringues, but I mean, it's that sort of level, that's overkill. Overkill is the wrong word, oversafe. And I think that's one of the things on the reactor front. In terms of nuclear, look, we are 90% more, 95% coal. And those stations are going to be out of action in 2025, 2030. They're falling apart now. We're not going to maintain them. What are you going to get with wind, which has got 1,000 megawatt power, but bugger all energy? Power, 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 energy. Power, 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 energy. For 20% of the time, they produce power when nature tells you. So what you need is what's called baseload capacity. Baseload capacity is about 70% of your peak capacity. And that's where you need coal, nuclear, gas, fracking. I mean, the springbuck will still run around in the Karoo. But Homo sapien won't run around in the Karoo if you don't start fracking. You're worried about springbuck and you're not worried about yourself and your own economy. So I think this is my feeling on the energy scene, that if we go into this, it's been delayed. I was a member of World Energy Council back in '92 when we were going to order 2 for installation and operation at Koeberg for 2002, 2 in 1986 to operate in 2006. We would have had a 6-pack at Koeberg in 2006. By 2007, they still hadn't decided to do anything. So, I mean, it's also, these are long-term strategies. And if you keep vacillating and putting it off, if you think South Africa is going to fail, don't put in nuclear. If you think it's got a chance of really roaring, look to 2015, you'll book 2025, and you'll say, 2015, and we've got a nuclear reactor, and at least we can keep the lights on. Maybe not the mines running, and then get another one. But you've got to get a baseline capacity. So it's very important what sort of... Now, you asked the first question, and I've forgotten what it is now.
I said that, CO2.
Thanks.
Really, we don't want to throw rubbish into the atmosphere, so cutting down on CO2 should, I believe, is a good thing.
I think you're absolutely right, because, for instance, amongst other things, what people don't realize is that the radiation level around coal-fired stations is bigger than a nuclear station, because they put out about 25 tons of uranium a day, which goes into the atmosphere. And also the CO2 brings about lung problems. So if you look at the well-being of people, then you must worry about CO2, and you must worry, but the costs of cleaning it up happen to be enormous. And so we're in an economy where we like going the Greek way, slowly but surely. And one has to be very careful as to how one spends one's money in what is a critical thing. Energy drives industry and progress, not the other way, which some people here are saying, we don't need that energy because we only have this much. Some people are saying, the Greens are saying, come down in energy. That way you're going to shut this place down, unfortunately. But fortunately, I don't think they'll listen to them. Sorry. Oh. And of course, the lung problem with CO2, massive problem. Yes, sorry.
Don, thanks very much. Just a clarification on the CO2 issue. There was a graph, it seemed from what Henny said, that what you were saying is that we're all agreeing that CO2 is increasing from the one graph, but that we're not the main cause of that. I mean, that 0.12% anthropogenic, that percentage, I mean, that's quite an evocative figure.
That's right.
So just for the clarification, it feels as though we could try and build as many coal-fired power stations as we want, and we're not going to have an appreciable effect on that CO2. So if I can take a provocative sentence back to my students, would you agree that if we replaced all the coal-fired power stations in the world with renewables, there would not be an appreciable impact on the CO2 level that's going into the atmosphere?
I wish I'd said that myself. Excellent. Yes, because the main CO2, 80% of the CO2 is in the oceans. This is another important thing. When the oceans are cold, they absorb more CO2. When they're warm, they emit. So if you get what is essentially thought of now, a solar event that lifts the temperature, you then get CO2. So the causal relationship is not CO2 causes temperature, but temperature forces CO2. Then you get a feedback loop, because CO2 through the greenhouse will obviously bring cooling. But that's not the dominant driver. And also, whereas I told you the residence time, IPCC says 16 to 30% of the CO2 in the atmosphere is anthropogenic, rubbish. And sorry, I say rubbish with respect. About maybe 3% or so on, but you cannot see it on the CO2 curve. It increases, increasing at 2.1 ppm per year, and it hasn't changed. No, thanks very much. Yes, may I use that, please? You haven't got personal rights on it. Great. Hello.
Hi, am I on? Dr. Mingay, you've done a pretty good hatchet job on the climate.
Only pretty
on
good.
The global warming. I don't agree with you at all, no.
No, but I mean, I only did a pretty good hatchet. I thought I did a good hatchet job.
Pretty good, because your choice of presentations was very selective to sort of support your argument, which is obviously the way things work. But I'm very glad to see that you at least acknowledge that CO2 is increasing. I was interested to hear now that you don't think it's due to coal-fired stations or the industrial age, when if you look at, for instance, the record they've got at Mauna Loa, there's the very distinct increase from what about in the 200s, it's over 400 now, and it's still going up. And as Professor Snyman said, we need to be concerned about that increase in carbon dioxide. We have the interglacial periods, and we've probably had the longest interglacial period now for the last 800,000 years. So we are due for another ice age anyway, due to natural forces such as you said, solar orbiting, the precession, the ecliptics and things. But I think I'm not going to go into the details of your arguments, but the important thing is to realize that we are increasing carbon dioxide, and it is now at levels which we haven't had for the last 2 or 3 million years. And we need to realize that the existence of people is dependent on a very narrow temperature range. And we don't know what the effect of 1 or 2 degrees is going to have. Certainly, in the time of the dinosaur, 5 million years ago, the temperatures were much warmer than what they are now. But we need to live in this state that we are now, and we have to try and conserve it. And it's like being in a motor car driving towards a cliff. You've got indications that the cliff is there, and you can either ignore it, or you can actually say, wait, perhaps we should try and slow down, and we need to see what is there. And this is the kind of cliff that we are heading for. And the question then is, should we decrease carbon dioxide into the atmosphere? Because we don't know where we are going. We've never been there before in human existence. Or do we actually start taking precautions? And that is what the question is there. And so we need to limit carbon dioxide going into the atmosphere. You were talking as well about the interests and saying that the IPCC has all the funding and...
Could we please split this into 2 chapters? I've got 12 questions at the moment,
Okay.
which I need to answer.
Have you got them listed down?
No, I've got them here.
Oh, okay, good. Well, shall I stop and you carry on?
Well, yes, let me talk more generally in answer to that. Of course, CO2 is increasing. The point is it doesn't have anything to do with global warming. Of course, we should stop CO2, but it'll stop our power in this country when what we put out is trivial compared to the increase every year, our total, that's put out in China. How are we going to impact on global warming by killing our own economy when China won't? Where's the sanity economic? Look, I'm involved with econometrics as well. And if you have a look at the economy and the realities of it, it's all very well being clean and all the rest. Certainly, Homo sapiens has been around for a long time, and you saw my statement there, adapt or die, because I don't think we are big enough to change nature. And nature is the CO2 that's in the oceans. 80% of it is there, 0.12%. If we take it to 0.13%, it's nothing. Out of 3.65, we make it 3.66. Trivial.
Well,
So you can do huge jobs. Then, yeah, sure, okay.
Carry on. You're talking about carbon dioxide in the ocean, and that's totally another story, because the acidification that's being created in the ocean is killing off a lot of life in the ocean, and that's another problem with carbon dioxide in the ocean. So there are so many ramifications. We don't understand the details of how it all works together. And some of these effects are very long term. For instance, the circulation in the ocean takes place over thousands of years. And so you can have an effect which only comes through many years later. So your little variations, perhaps they need to be looked at in that longer term context. But just on another thing, you're talking about interests, and of course the coal and gas interests are incredibly strong, and their lobbies in terms of financial support is such that, well, I'm a member of the American Geophysical Union, and in the 1990s, if an American put into his...
Could I ask, I'm running out of memory at the moment.
Well,
I thought I had 30
can I
gigabytes,
just-
but I don't. I've only got 17 gigabytes.
Would you
And so may I
just ask a few questions, because the way I see it, we need energy, and we are not against cleaning up the atmosphere, but at the moment we need to burn, unfortunately, the fossil fuels because we have to survive. But long term, we would see that to be stopped completely. But please just ask a question, 1 or 2, and stick to the point.
I think I'd like to try and answer a couple, though. For instance, you said ocean effects are long-term. Absolutely not. We're going to an El Nino and then a La Nina right now, which will affect the temperature, and we can do it. I didn't have time to talk about it on that time. But the Pacific decadal oscillation is important. ENSO is important. The Atlantic multi-decadal oscillation is important for the Arctic ice. These are driven by temperature differences. Those temperature differences are driven by not CO2.
Agreeing
No,
with,
look,
with
I'm sorry,
everything
you've had a lot of time. I've been very patient.
So we were
And I think,
yeah.
well, okay.
I'm sorry.
What I'd love to do is respond to all of those points because I have responses for all of them. And unfortunately, one of the other things that you put up is one thing that I didn't put up with the polar bears and the sea ice rising and all the rest is another green pontification about something which is not happening. Go and talk to the Polar Bear Association and say, what's going on? They're growing in Hudson Bay from 9,000 to 10,000. And 2/3 of the polar bear can't be seen. Now, why does the IPCC talk about polar bears?
Well,
And you're talking about something else. I'm sorry.
So I have to
look,
interrupt.
I would like a democratic solution. Would you like this discussion to go on? Please put up your hands. Would you like it to end?
Yeah, we would like to end now. We would like to give another.
Thank you. And I apologize. I have great feeling for you, and I'm available afterwards to talk to you, because there are a lot of factors which you raised which are vitally important in terms of the impressions of people that need to be explained and sorted. So thank you very much. I appreciate it.
So now the next delegate.
Sorry, Prof, can I just raise a point? It's not really a question, but just to say to Prof Neertling, I really appreciate the opportunity to participate in what should be a debate. But in order for there to be a balanced viewpoint, I really feel that should there be a similar opportunity in the future, that someone from, let's call it the opposing camp, actually does a similar presentation who can validate and
May I
do their
interrupt?
things.
I've offered for you three at the Baxter to do a debate on the stage, as I've done on nuclear, and won it against the Green, hands down. I've offered to do climate change against, I can give you their names, none of them will stand on the stage. None of them. And what's more, they've offered it with 11 people. I said, I want 400 people before I debate with you. Because they're those of us who've got experience of what is said and what in small groups can be
I don't
abused.
doubt that,
And so what I'm saying to you is that I'm open to debate anytime, and I would appreciate it. I really would.
Thank you.
As I have mentioned before, it's important for the scientists to look at all the arguments. In the end, we want to really use the existing data to be able to arrive at conclusions which are as accurately as we can determine. So please ask more. Anyone else? Okay.
Thanks. Hello there.
Good evening. I think there's been a misnomer in the media, popular culture about global warming, global cooling. Climate change, in my understanding, is not limited to temperature. It's not limited to increases or decreases in temperature. It takes into account all the long-term meteorological effects that are involved. That includes cloud formation, which was mentioned once. It includes also, and I think what's an important point, the retention of heat in the atmosphere.
Yes.
In that regard, the sun can do a lot of things, but if the atmosphere is not able to retain the heat, it cannot get warmer. What I'm asking, I saw a lot of correlations between solar activity and cosmic rays. Now, from a solar modulation perspective, that can be explained. However, what I'm missing and what I would like to inquire about is the the mechanism through which cosmic rays incident on the atmosphere or any other effect for that matter actually contributes to cloud formation, for example, or any other meteorological factors that would actually be able to contain heat or dissipate it, change hydrological cycles, precipitation, those things. How does space affect? What mechanism exists? What physical microscopic mechanism exists for space-related effects to actually impact the atmosphere?
Excellent, because I did that in my honours year at WITS about 70 years ago, where I had to build a cloud chamber which had a supercritical water vapor in it, and as such, by shooting an alpha particle through, you could see tracks. And in the early nuclear physics days, they used cloud chambers to show the tracks. Why? Because the radiation nucleates in an otherwise supersaturated, nucleates to make big enough little nuclei for formation to go ahead. Below a certain level, for instance, you're quite right, that for CO2, if you run a beam through CO2, it will not actually nucleate to make water droplets. It won't. But CO2 coupled to an amine or any like that is different, and it can nucleate. And so what you're doing is you're making a very microstructure big enough that your surface tension capabilities build rather than evaporate. And so this is the form of nucleation of clouds, and this is why they shoot carbon dioxide into the atmosphere, all the rest. No different to forming nuclei as it is with radiation, which is cosmic rays.
Second part to that question,
Yeah.
please. What intensity, thinking in terms of input, what intensity of cosmic rays or particles is needed for such an effect to be substantially significant enough to say be more prevalent than the effects of whatever tons are quoted is pumped into the atmosphere through fossil fuel combustion?
Yeah, I think I showed that, first of all, in experimental work on the ground, where that cloud chamber simulated conditions in the troposphere in particular. And the troposphere is important, and as you say, temperature up there is important, and that's where the IPCC models get it wrong, as I showed. What you have to do there is say, you know, the conditions for doing that was searched for in the lab and found. That's why I can quote this about not going on CO2. If you want it, you can look at the reference. It's about 6 years ago now. But when you look at cloud formation as well, I showed one here. I think I remember it, of cloud formation coupled to cosmic rays. And there's a correlation. Now, I can't undo nature, even if I want to, so it doesn't matter what. And the cosmic rays, remember, come in a multitude of energies and types and styles, including neutrinos, which go right through without touching anything. You're full of them at the moment, so are we all. And so the evidence there, the evidential stuff in terms of climatology is there. And more than that, I find difficult to say. Sorry, but it's the best I can do.
So we will allow one more, and then unfortunately we will have to stop for the evening. But if you want us to invite Don again to come to Port Elizabeth, we can do it. One more.
And what I'll do is I'll wait up here. Anyone who wants to come and talk personally, I'm available.
Hi, good evening. I'm a school teacher, and for lack of a better way of explaining it, we are very much into teaching the Al Gore school of thought to our grade 11s. I just want to know, do you have any recommended reading that we could give to the kids so that they can have a different school of thought, so that we can encourage independent thinking on their part? Because if this is another way of thinking of things and leading into a different, I don't know, for again, lack of better word for a different school of thought, what would you recommend that we read? And I'm sure a lot of us that are around here now would also like to read some more about your thoughts and your presentation.
You are critically important. Teachers are critically important in this because the youth are getting the wrong idea, and it's being propagated, I shan't name, but from a local university where I am, there are two people from climatology group, one certainly, who goes around to schools propagating CO2 warming. Now, what happens when you get an expert, from a climatologist from a university going to a school and propagating that? You as a teacher, I feel for desperately, because that is a sequence where he's paid and his job depends on that. If he turns his feelings around, he's in trouble. Although if the university is really honest, they won't. And I think this is the big, big problem that you face and that we face, is getting the truth, or at least the argument out as to what else is happening. IPCC have done nothing other than Homo sapien influence. Nothing. They had one astrophysicist type who pointed out that the total solar incidence, the sun doesn't change much, so therefore the sun can't do anything. Didn't look at the rest. They are single-minded, one-to-one CO2 to temperature. It's much more complex than that, much more complex than I put up here. This is simplistic. But what I'm trying to show is that there are other ways of actually presenting this. And you are in a tough position. I wish you well. And if I'm around, I'll come to that school and I'll talk for 5 hours.
Oh, awesome. But is there anything that you could recommend us that I could read and maybe summarize for the kids or for the learners?
Yeah, it calls for a lot of work. I think the summary you must make is that 99% of our heat comes from the sun, that it can, through its effect, vary and make temperature change as it has done over hundreds of thousands of years, and that the IPCC CO2 only fits from 1974 thereabouts to 1998. The hiatus that they call it since then, 18 years, is flat. I think that's one massive argument. Just ask them to explain the hiatus. How do they explain it? They fall down. Thank you, and good luck. Reinhardt.
Not your turn yet, it's mine first, for another half an hour, those of you who stayed so late. Ladies and gentlemen, there's really nothing I can add to this proceedings. All I can do is thank Don. He certainly entertained us. He's brave. You can see the lion there running away from the buffalo.
Leading them into a trap.
He probably hasn't convinced all of us of his point of view, but he's given us some food for thought. Don, I want you to keep letting your voice be heard. It's good to hear the other side of the story. It's important that society and, well, scientists and also society in general think critically about the information that they are fed. As a small token of appreciation, I want to present this to you. I hope you'll remember this memorable occasion.
Thank you. Thank you very much. And really, for all the work that you and Andre and the others have done here, magnificent meeting. I congratulate you all. And to you who've been so patient, in spite of a voice that's disappearing and coming back again, thank you very much. It's been a great pleasure and an honor to be here. Thank you.
Thank you once again. Also to Professor Neerden, my colleague, for acting as chairperson tonight and for the way that you've handled the questions afterwards. Cape Lasers for the laser show at the start of this proceedings, and to you, the members of the public who took the time to come out here to listen to our invited speaker, our specialist. Drive home safely, and I hope we'll see all of you here on Thursday It will be a less controversial topic, but I'm sure it will be as entertaining. Good night.